By accident, I left the lid off my orange marker, and now we have to use the ugly green color instead, which so totally sucks because the orange was my favorite color. But now we're using the green color. So welcome to Organic Chemistry for Biohackers, episode 8 or 9 or 7, one of them. And we are doing DNA damage. This is part 2 of the episode all about free radicals. We are specifically focusing on DNA damage caused by superoxide anion. Superoxide anion is probably the most dangerous reactive oxygen species that exists in your body. And we are going over exactly how it damages DNA, how it causes DNA mutation, and may increase risk of cancer. Firstly, to understand how superoxide anion damages DNA, we need to understand what good, normal, healthy, happy DNA looks like. So superoxide anion specifically can damage the base guanine and turn it into 8-oxo guanine. 8-oxo guanine is highly mutagenic, meaning it can lead to mutations. Let's draw what good, healthy, normal. Hey, my cat just came in. One moment, please. This is my cat. His name's Tiger. Oh, where the frick did I put my marker? One moment, please. Okay, I have my ugly green marker. Now I'm going to draw guanine and cytosine doing their good, normal, healthy base pairing that you see in good, normal, healthy DNA. This is guanine, this is cytosine. Guanine and cytosine are both nitrogenous bases, and they are found in your DNA. DNA has 4 nitrogenous bases: adenine, guanine, cytosine, and thymine. Guanine always pairs with cytosine. Adenine always pairs with thymine. DNA is what codes for proteins and specific enzymes to be made in your cells. So DNA is literally what tells your body what to do, how to do it, when to do it, and why to do it. All those instructions are encoded in the patterns of guanine, cytosine, adenine, and thymine. So the specific pattern of these nitrogenous bases is what is directing and informing cellular activities, metabolic pathways, hormone synthesis, growth, repair. Even if DNA gets damaged, DNA itself is what's encoding for the enzymes that are going to come along and repair DNA. Everything starts in DNA. DNA is a double-stranded molecule, so here is one strand on this side and the other strand on this side. Here's one guanine on this one strand. Here is a cytosine on the other strand. Guanine and cytosine make 3 hydrogen bonds. These things sticking off of guanine, oxygen, hydrogen, hydrogen, oxygen, nitrogen, hydrogen here, they complement each other. So it's called complementary base pairing because the geometries and the hydrogen bonds these atoms are able to make perfectly complement the hydrogen bonds and the geometry of cytosine. So guanine is always with cytosine because they complement each other and they can make these specific hydrogen bonds. When you have superoxide anion oxidizing DNA, damaging DNA, him with his extra electron, this super nasty molecule, goes zap, and he zaps right here on the base guanine, breaks this double bond, and inserts himself right here. So now this is no longer guanine, this is 8-oxo guanine. Now because he has this carbonyl group, this double bond O right here, it changes the way guanine is existing in your cell. So now instead of guanine existing just like this and making 3 hydrogen bonds with cytosine, because of this big, bulky, brand new, not supposed to be there carbonyl group, it causes guanine to flip around in your cell. So guanine spins around, and when he spins around, this stuff is no longer over here able to hydrogen bond with cytosine. It's flipped around, and now this part is kind of sticking in to the middle of DNA. When you have a different part of guanine sticking into DNA, it is much more favorable now for this 8-oxo guanine to base pair with adenine. So now instead of having a guanine cytosine pair, you have a guanine adenine pair. What this now means is that one strand of your DNA still has guanine, 8-oxo guanine, it still has the G, but the other strand of your DNA, which is supposed to have cytosine, now has adenine. If that DNA damage goes unrepaired, if DNA stays in its 8-oxo guanine adenine bond, and you go through cell division and DNA replication, you've now just caused a permanent mutation. That other strand of DNA had an adenine in place, that adenine in place has been replicated, and now the new set of DNA has an adenine where it should have had a cytosine, or it has a that new DNA will now have an AT pair where there's supposed to be a GC pair. Now that new DNA is permanently mutated, and this mutation can change what protein the DNA is coding for, or the enzyme the DNA is coding for, and ultimately a lot of cancer and diseases are driven by DNA mutation. So now I'm going to show you what that 8-oxo guanine actually looks like. This is 8-oxo guanine bonding with adenine. So see, 8-oxo guanine has been flipped around and spun around, and now because different atoms are being projected into the inside of DNA's helix, he's favorably bonding with adenine. So on this side we have guanine, on this side we have adenine. If this cell with this specific case of DNA damage, the oxidized guanine, if this cell replicates its DNA, one strand is going to have an adenine, bad. This strand is going to have 8-oxo guanine. And this strand is now going to be mutated. This adenine will complementary base pair with thymine. This oxo guanine might get fixed. It might base pair with adenine again, or it might base pair with cytosine. I'm not entirely sure what's going on over here, but over here we now have a mutation. We have adenine, thymine replacing what should be guanine and cytosine. This totally screws up what protein or enzyme is supposed to be produced from the DNA, because we now have a mutation, a permanent change in the DNA code. This mutation can cause diseases, proteinopathies, so like diseases of protein misfolding, loss of function in certain enzymes, and it can cause cancer. How did we even end up in this mess? Well, a superoxide anion, a reactive oxygen species, zapped guanine. It broke a double bond right here, and it created a carbonyl group. Addition of this carbonyl group spun guanine around, changed the atoms projecting into the DNA helix, which made it more favorable for this new 8-oxo guanine, 8 oxidized because it's oxidized on the 8th carbon, to favorably bond with adenine instead of bond with cytosine. That has caused the DNA damage. Ideally, a DNA repair enzyme will come along and fix this whole situation, get rid of this thing here, and then guanine will spin around again and favorably bond with cytosine instead of adenine. If the damage goes unrepaired and the cell replicates its DNA, then you're stuck with a mutation and you will have an AT mutation where there should be a GC pair. That is how superoxide anion is damaging your DNA and increasing risk of certain diseases and cancer. If you want to learn more about free radicals, see my previous video, episode 6 or 7, all about free radicals. This video was produced by myself as part of a series, Organic Chemistry for Biohackers. And if you want the complete set of notes complementing the series, go to my website, nutritionbyelsa.com. You can find all the notes and all my resources and citations there. If you got any value whatsoever out of this video, comment, subscribe, like this video, share it with your cute little nerdy girlfriends. Okay, everybody, have a really good day. And I hope you got as excited about this as me, because I think this is so exciting and I love it so much. Goodbye.